According to NFPA 780 standard for the installation of lightning protection systems, there are minimum requirements for lightning protection. Surge protection devices, or SPDs, are required for buildings and structures that contain electrical or electronic systems critical to life, health, or safety. A lightning protection system is required for buildings and structures that meet specific criteria, including buildings taller than 75 feet, which is about 23 meters, buildings with large roof areas exceeding 25,000 square feet, buildings with hazardous contents such as explosives or flammable materials, and buildings in areas with a high incidence of lightning strikes. The minimum height requirement for lightning protection is 75 feet, or about 23 meters. Buildings with heights below this threshold are not typically required to have lightning protection unless they meet other criteria, like hazardous contents. To determine if lightning protection is required or not required for a specific building, consider these factors. Firstly, height. Buildings taller than 75 feet, again about 23 meters, typically require lightning protection. Secondly, roof area. Buildings with large roof areas exceeding 25,000 square feet may require lightning protection. Thirdly, contents. Buildings that contain hazardous materials or critical electrical or electronic systems may require lightning protection. Fourthly, location. Areas with a high incidence of lightning strikes may require lightning protection, even for buildings below 75 feet in height. Lastly, code requirements. Local building codes and regulations should be consulted to determine the specific requirements for lightning protection in your area. If you are unsure whether lightning protection is required for your building, it is advisable to consult with a qualified electrical engineer or lightning protection professional for an assessment. Consider the following factors for a more detailed determination: height, roof area, contents, location, and code requirements. If the building is taller than 75 feet, which is approximately 23 meters, lightning protection is generally required. For buildings with large roof areas exceeding 25,000 square feet, lightning protection might be necessary due to the increased surface area vulnerable to lightning strikes. If the building houses hazardous materials like explosives or flammable substances, or contains critical electrical or electronic systems essential for life safety or health, lightning protection is crucial. Buildings situated in regions with a high frequency of lightning strikes may necessitate protection regardless of their height. Always refer to local building codes and regulations to ascertain the specific requirements for lightning protection applicable in your area. Consulting with a qualified electrical engineer or lightning protection specialist is recommended for a comprehensive assessment to determine whether lightning protection is needed for a particular building. Remember that the presence of hazardous materials significantly increases the need for lightning protection to mitigate the risk of fire or explosion. Critical electrical systems, such as those in hospitals or emergency response centers, demand lightning protection to ensure uninterrupted operation during electrical storms. High lightning strike areas pose a greater risk, making protection a prudent measure even for smaller buildings. The NFPA 780 standard provides detailed guidelines on the design, installation, and maintenance of lightning protection systems. These systems typically consist of air terminals, also known as lightning rods, conductors, and grounding electrodes. Air terminals are installed on the roof of the building to intercept lightning strikes. Conductors provide a low impedance path for the lightning current to flow to ground. Grounding electrodes dissipate the lightning current into the earth. Proper grounding is essential for effective lightning protection. The grounding system should have a low resistance to earth to minimize the voltage rise during a lightning strike. Regular inspection and maintenance of the lightning protection system are necessary to ensure its continued effectiveness. Damaged or corroded components should be replaced promptly. Keep detailed records of inspections and maintenance activities. Consider the specific characteristics of your building and its surroundings when designing a lightning protection system. Factors such as building height, shape, construction materials, and proximity to other structures can influence the effectiveness of the protection system. The goal of lightning protection is to minimize the risk of damage to the building and its contents, as well as to protect occupants from injury. Lightning strikes can cause fires, explosions, and electrical surges that can damage equipment and endanger lives. A properly designed and installed lightning protection system can significantly reduce these risks. Consider the cost-benefit of lightning protection when making your decision. While the initial investment may seem significant, the potential cost of damage from a lightning strike can be much higher. The cost of downtime, repairs, and replacement of equipment can quickly add up. In addition to protecting the building and its contents, lightning protection can also provide peace of mind. Knowing that your building is protected from lightning strikes can help you sleep better at night, especially during severe thunderstorms. Stay informed about the latest developments in lightning protection technology and standards. The NFPA 780 standard is updated periodically to reflect new research and best practices. Make sure your lightning protection system complies with the latest requirements. Consult with a qualified electrical engineer or lightning protection professional to ensure that your system is properly designed, installed, and maintained. These experts can assess your specific needs and recommend the best solution for your building. Remember that lightning protection is not a one-size-fits-all solution. The design of the system should be tailored to the specific characteristics of your building and its surroundings. Consider the aesthetic impact of the lightning protection system. While functionality is the primary concern, it is possible to design a system that is both effective and visually appealing. Choose materials and components that blend in with the building's architecture. A well-designed lightning protection system can enhance the overall appearance of your building. Consider the long-term maintenance requirements of the lightning protection system. Choose materials and components that are durable and require minimal maintenance. Regular inspections are essential to ensure the system's continued effectiveness. Develop a maintenance plan that includes periodic inspections, testing, and repairs. Keep accurate records of all maintenance activities. Consider the impact of climate change on lightning activity. Some studies suggest that lightning strikes may become more frequent and intense in the future. This could increase the need for lightning protection in areas that are not currently considered high risk. Stay informed about the latest research on climate change and its potential impact on lightning activity. Consider the use of lightning warning systems. These systems can provide early warning of approaching thunderstorms, allowing you to take precautions such as shutting down sensitive equipment and evacuating buildings. Lightning warning systems can be particularly useful for outdoor events and activities. Consider the use of surge protection devices in addition to a lightning protection system. Surge protection devices can help protect electronic equipment from damage caused by electrical surges, which can occur even when a building is equipped with a lightning protection system. Install surge protection devices at the main electrical panel and at individual outlets. Choose surge protection devices that are rated for the voltage and current requirements of your equipment. Consider the use of uninterruptible power supplies, or UPSs, for critical equipment. UPS can provide backup power in the event of a power outage caused by a lightning strike or other electrical disturbance. Choose UPS that are rated for the power requirements of your equipment. Consider the use of fiber optic cables for data transmission. Fiber optic cables are immune to electrical interference and can help protect sensitive electronic equipment from damage caused by lightning strikes. Replace copper cables with fiber optic cables where possible. Consider the use of shielded cables for power and data transmission. Shielded cables can help reduce the amount of electrical noise that is radiated from the cables, which can help protect sensitive electronic equipment from damage caused by lightning strikes. Use shielded cables for all critical power and data connections. Consider the use of lightning-resistant building materials. Some building materials are more resistant to lightning strikes than others. For example, concrete and steel are more resistant to lightning strikes than wood. Use lightning-resistant building materials where possible. Consider the use of grounding mats in areas where people are likely to be exposed to lightning strikes. Grounding mats can help protect people from electrical shock by providing a low-resistance path to ground. Install grounding mats in areas such as swimming pools, patios, and decks. Consider the use of lightning shelters in areas where people are likely to be caught in a lightning storm. Lightning shelters can provide a safe place to take refuge during a lightning storm. Build lightning shelters in parks, campgrounds, and other outdoor areas. Educate people about lightning safety. Teach people how to protect themselves from lightning strikes. Provide information about lightning safety in schools, workplaces, and public places. Encourage people to seek shelter indoors during lightning storms. Encourage people to avoid using electronic devices during lightning storms. Encourage people to stay away from metal objects during lightning storms. Encourage people to call for help if someone is struck by lightning. Provide first aid training for lightning strike victims. Teach people how to provide CPR and other first aid measures to lightning strike victims. Keep a first aid kit readily available in case of a lightning strike. Support research on lightning protection. Invest in research to improve lightning protection technology and standards. Encourage universities and research institutions to conduct research on lightning. Share research findings with the public. Promote the adoption of lightning protection measures. Encourage building owners and managers to install lightning protection systems. Promote the use of lightning-resistant building materials. Promote the education of people about lightning safety. Work with government agencies and industry organizations to promote the adoption of lightning protection measures. Remember that lightning protection is a shared responsibility. Everyone has a role to play in protecting themselves and others from lightning strikes. By taking simple precautions, you can significantly reduce the risk of lightning-related injuries and damage.